So now we'll start with the first step of the setting model-based testing is to create a test context. So in model-based testing package, I will create a block diagram dedicated for that. We'll create a block system context block. I will call it testing context. And will take my part of the system which I want to test is digital electric control unit and make it part of this test. That's it. So now whatever is related to this testing will be in this context, and test context is using system. So system is independent, and that's how we separate the system from analysis and testing. Now let's go to the next step, and this will be capturing system execution scenarios as sequence diagram. So because we are using, we'll use them in the context of testing, so we'll capture them when we execute the system as part of the test context. And this will ensure that we will run in the proper context. So I'm starting system, and pretty much I will start this monitoring of this state machine, and right click on the variables panel, create sequence diagram. This is how I start capturing this execution as a sequence diagram. Put the two windows in parallel, and here we'll see the state machine, and here we'll see the sequence diagram. So I will run now the execution. I will start behavior. And as you can see here, sequence diagram starts capturing states, transitions, property changes, and if we will set up configuration later on, we can capture also time duration. Now I will send here for the deco. As you can see, I need to select the part, where to send the signal. So flame out. And system switch to the check engine speed. I will send engine speed, and system switches to the auto relight because this is the parameters which it responds to. So like if non-dimensional rotational speed is more than auto relight threshold, it switches to auto relight threshold, and we can see these parameters here. We can see them here. And so on. So now I captured one sequence diagram as a path which we went through the execution, and now I can run it. If I will run with context, I will check that it is actually working as expected. So you see, I can run with context sequence diagram, and this should execute and control my simulation. So I'm running it. That shows that it is suitable for us to use as a test case because it is already executing and already achieving what we want. It is just scenario, right? But this is a scenario which we expect to be used as a test case. Now I will capture a couple of more scenarios. Again, I will go back to this test context simulation run, and will capture scenarios to test requirements that system based on the specific characteristic will result in this pretty much in different restart methods. So this one, and this one. So, and for that, first one was default because the parameters were default. The second one will be this one, spool down restart. So I need to change parameters. So I will set the speed to 65%, and we'll capture this execution in sequence diagram. So I will add it here, this one here, and run it. Okay. Now we'll send flame out, and I can increase the speed. There is no need to engine speed. Okay, and stop it. So this is the second test, and then the next one again. Start. Capture the sequence diagram. Put it here. put the parameters in the different configuration. This will be like windmill restart, so altitude windmill, so will be inside windmill off. So you see that I see those parameters changed, captured automatically because I changed the properties. And speed, let's say 25%, you see it's changed. Run it, deco, flame out, engine speed, aircraft prepared. Done. So I captured one more and stop, run again, and the last one. So will be again, I will create sequence diagram. Now we'll configure this one, and this will be, that's correct, and that will be 25, and we'll start this one. Okay. Flame out, speed, aircraft prepared. Okay, this one. So it is expected. So now we will convert those sequence diagrams into the test cases. So here we see those sequence diagrams. They are all captured here. I will close them. So to convert them to the test case, we need to apply test case stereotype. So first of all, I will take all of them and select them with control click and move to the testing context. Inside of the testing context, and we'll delete those blocks. I don't need those which were automatically created. I will just have sequence diagrams, and I will apply for all of them stereotype test context test case stereotype. What happens when you apply the stereotype? It is SysML stereotype. You get return verdict parameter, which will get the value based on the execution results. So now when you apply this test case stereotype, it's no longer a sequence diagram. It's treated, this sequence diagram as a regular sequence diagram is treated as a test case. If it responds in incorrect state or property value, it will fail and the verdict will be failed. If it will continue and pass through all the steps, it will verdict generate pass. So that's how we convert to the test case. And one more thing, because we want to see that it tests the right thing, so I will just name it test auto relight, test spool down restart, test windmill restart, and last one, test start assisted restart. And just last thing, I think I will remove those property changes. I will pass the configuration of the system with the property changes before test. So I don't need that test would include any property changes, which could make sense also. So now how to tie those tests to requirements. And as you know, in SysML, there is a verify relationship, which ties the test case to requirement. So I will take those test cases, they are here. And I will take requirements, that will be system requirements. So let me go to the solution domain, system requirements here. And there are system requirements which derive from stakeholder needs, which pretty much describes the system restart methods like windmill restart, assisted restart, auto relight restart, and spool down restart. Okay, those are different restart methods. This one. Okay, as you can see, the grouping requirement here, it derives from stakeholder need at some level. Here we see this derives from stakeholder need. And that's how we know which one they are coming from. But they already have the specific logic for the restart. Like for example, if non-dimensional rotational speed is more than auto-relight threshold, auto-relight restart shall be initiated automatically. And this comes from the activity diagram, which was described as part of functional analysis, and this requirement got captured. So here we see this refined activity diagram. Okay, so now we'll go here and we'll actually come back, right click, select in containment tree. Those are requirements which we want to tie to test cases. You can do that in matrix. There is a dedicated verify matrix. You can do it here. So spool down restart. This is the requirement test case verifies. Mill restart, assisted restart, and auto relight restart. Here you go. So now we'll show how to orchestrate test cases in the activity diagram as part of testing context. So for that, first of all, we'll create value properties in test context, test one, and type of this test one will be verdict kind. And then will be test 2 with control drag. You see I can copy and create more tests, and 5 tests, just one will be not used. And I also like to add the default type. I unfortunately on the multi-select I think I can't add it here, so I will just select add by default will be inconclusive, in order that I would know that this verdict is not pass or fail, but it is not executed and stays like this until test will run. Now I have those tests which I will get as a result of execution, and now sequence of execution will be captured in activity diagram. This is kind of the popular way to capture the workflow. So create diagram, activity diagram like this. And now I will take those sequence diagrams, drop them here. And as you know, as you can see, they have the verdict parameter, which is represented as a pin. And I can sort them by any order desired, and will have the sequence like this of test execution. I will put the opaque behavior, which will result into the ability to capture. So here you see by name of the pin, I will capture the result of the verdict to test 1. And this is another one, again opaque behavior, test 2 will be, and this is here, and then test test 3 equal v, and the last one will be test 4 equal v, and this will end my execution sequence. So I will end it with activity final. That's how I know that this will end simulation. And this is important when you run specifically automatic execution, because you want to be sure that your simulation ended, and this will be final action, final activity node, which will definitely end this activity. So that's it. And one more thing is actually we put them in the sequence, but we need to make this activity as a main behavior of this test context, because we dragged those sequence diagrams before. So the main test context for the behavior for the test context is not clear. You see classifier behavior is not assigned even yet. It could be something, but it's not assigned. And we need to assign this test context, because this is the one which will execute and will control those one by one will call. So we'll test that it works. I will take them from deco. I will take sequence state machine, put it here just to see what's happening. will go like this. We'll do some alignment like this, like this. It doesn't matter. And then we'll run with context. So test case executed. Slow down, run. So let's see that it works. Okay, it works. So it executes the first one and should end up here. Okay, done. Now the next one will fail because it starts from the beginning. Each of them starts from the beginning. And as you can see, the result is failed, 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 because as you can see, it starts from the flame out. And the flame out at this moment when system is here is not feasible because it is here. So we need to reset between tests. System needs to be reset. Plus we need configuration of the system specific for those with those properties to test specific configuration. So this we will show how to do in the next step. Okay, so now we'll show how to reset system configuration after each test, which is very important to start from scratch. Let's say if test failed or test end up somewhere as we see, and even more to input the required configuration of the system into that as a new system. So how to input required system configuration, how to get that required system configuration. So required system configuration is pretty much instance of the system, right? So to do it, we need to create instances with the properties of the system, which we could capture before when we were capturing those sequence diagrams, right, of the system with the configurations set up by us, but we can do it now. So we'll go to model-based testing, we'll right-click and we'll create a new package. So we'll call it system configurations, and we'll put here instance table, and we'll create a classifier of that. It will be my system. You see, I got many properties out of the box. I don't need ports, I will just hide whatever properties I don't need. So many properties. Now I will show that system configuration is my package for the scope of the instances, and I will check what properties do I need actually. So I need this one. I don't need all of them actually. And I need auto relight threshold inside windmill pull down threshold and this one, and I could get more, but that's okay. Okay, and now I will create system configurations. Create with parts, or just create, and I get those system configurations for each test. So first of all, one will be the default one. I might not need to input the configuration. Second one will be the test pull down restart. So I will name this configuration pull down restart configuration. The next one will be windmill configuration. Then the last one will be assisted restart configuration. Okay, so for this one, we need this in between those two boundaries. So let's say 65 and then those doesn't matter really because as you can see here, they matter only this, and we are talking about this choice here. And for those two, we will need to actually put this one lower, 25, or something like this. And here will be windmiller start this true, this false, and this true, this false, this true. So this is following this path. So this one or this one, based on the choices. Okay, and now, so we have them as instances, right? And that could include many different properties of the system, and that's like very good. We can save the system configuration as instance at multi-level of the system structure, and then input before the test, and at the same time reset the system. So how to do it? Now let's go here. So I will create first just regular activity. and then go here and that I could call, will be pull down restart. Okay, we'll create activity diagram inside. Well, this will be by choosing value specification action and by choosing add structural feature value action. So value specification, structural feature action will be property here. Deco is the property in the test case which refers to the system. So this is the property I want to input another instance of that system, but I want to replace it. So I go to the specification of this element is replace all true. You see is replace all true. When we input, it will replace. And here I could put the block of the deco, but I could put the instance of the block. And that's even better for me. So spool down restart instance will come here and I will pass it here. That's it. So this is how I will deal with this solution. And this is very good solution actually, because it takes at every step, it resets and configures. If you just need to reset, again, just input the block here, this deco block here. But if you need, instance, you can get instance also. Okay, so now next step is again, this will be when the mill restart. Again, create that, and then you could actually maybe, somehow automate this by reusing those elements, but for me right now, it is just easier to create them, and then this will be add. This will be when mill restart, and this will be again deco, and we are connected. So quite simple structure here, and using the action semantic, we can reset system. And then the last one will be assisted restart. Okay, so that's what we expected here. And now I will test this execution running this scenario here and seeing that it is resetting to right conditions, and then checking that tests pass or fail. So I will run in context. You see those tests here, and we can slow down, we can run. So tests are running. We see that tests will control the system. System ended and test ended, and we get the verdict, and the verdict was passed, as you can see. So system reset. You can check what is the system configuration at this moment, and you see like I fail, and there could be some reason for that. Okay, let's check. So for example, one reason is that this one is not replace all should be true, and this is replace all should be true, right? Because it should replace that. I could put breakpoint here, but I just will wait, and this will start executing and it will pause. Okay, so let's see. Okay, I got this, you see, instance of the system going here, right? And this should reset my system to initial configuration. Okay, now next comes here, next comes here, and now next it will reset, and then we'll start this next one, which will end up in spool down restart. So let's see. And see, it's failed at this one. So pretty much it doesn't expect that it will be in running state. It means that it didn't reset the system configuration. So let's see what's happening here. Not to forget that we need to add here not the object as a pin input, but the value for this structural feature. So this object pin is not suitable for us. We need to create a value pin. So you can see here and replace that. So we will do the same for and see system running correctly or not. So you will see this number change. This is the new instance of the system replacing the object of deco. You see it's replaced as new. So this next will end up in different state, as you can see. You see here in the state machine cumulative, visited path of all the different tests. And we see here running one by one, and all of them are correctly passing the test. We'll do any mistake here. So if the system changes because of some requirement change and architecture change, we can rerun that and we'll get result which will be likely different if we'll mess with any this logic. So next, we want now to capture those test results into the file or instance in the model with timestamp, and we don't want to have this just like visible at every execution and then disappear, right? So let's create a new package for that. Test results. And in that package, for now there is nothing, but here in model-based testing, I will create a simulation configuration. So there will be new type of diagram, simulation configuration needed, which will be called engine restart testing engine restart. And this will be running test context. As you can see, I can drag and set the context. And the results specification, results location will be this test results package, which will get results. So this every run, it will get the instance of this block, which is execution target block, get instance of that. And now I could show those instances in instance table. So I can create instance table inside test result package, set the classifier as the test context. We see all verdicts here and set scope as my test results package. Okay, so now let's save this model. And let's run this config. You see, once config is created, I can see this config here. So let's run it. And I see the tests going, and passing one by one. All good. All good. All good. Still takes some time to execute, right? Still takes some time to execute. And once everything is done, I see those tests passed. This was not even started because it was just not needed. And now how to speed up this execution. So go to the config, and here you can provide multiple properties of the configuration. One of them is the animation speed. So let's put it 100. And even we can do like silent, in that case, no animation, just like execution. And this will be as fast as it can be. So run test. Result is here. So change something in the system to fail the test, like for example this one, just to say like more instead of less, run test, failed. So we can go back, and you can see also that it identifies that this test was failed. Here we see test is failed. Okay, let's go back and fix that part. Run test again. So it was as quick as it can be, right? No visual representation of the execution, just like test. And as you can see, there is no timestamp. So again, another property in simulation config, there is record timestamp, run again. Now we see timestamp. So we see when the test was executed. Okay, now we have that testing set up. Everything is in order. The last step is to automate this execution, that you would not need to run this manually, that it would run automatically, and that we can do from command line. You can go here to docsnomagic.com, type the command line SysML or simulation, and you will see how to execute. Here is the command line where you will execute this config to run the tests automatically. So let's do it. Let's run the test automatically. So let me go, and you can see here. So first part of this is the path to your project. The second part is the config name, and you need to execute it in the location of your simulation package. There is the bat file, which simulation bat file, which will execute this config. Simulate is the name of the bat file which will execute this project. So it will execute in headless mode and will produce results. So you can think, okay, it will execute in headless mode and produce results. How I will get those results? So first of all, I will go here and config to set up that I would get results. So CSV export is the perfect way. So test results. It will just write to file. So again, the same test context is a represents element, and then name test results CSV, and then values will be just the values of tests. And I could pick any other property value to see what's happening in the system, and then right to the end, it will write only the last change of the properties, that writing every line per every change of the properties. Okay, and then I will drag it on config to make it as execution listener. And I can run this here and see that file gets created at the same level as a project. So if I will double click on the file, I see it was executed here, and it took 255 milliseconds to execute it. Okay, so now let's do it. Let's delete this file. Let's set up the execution. So I will copy the project name. Here will be my project name. So where's the? Let's do it on the clean sheet. New notepad. That's the project name. I will copy the path to the project. That will be the path to the project. I will copy my installation of the tool, and that will include the plugins simulation path here. Okay. And the last parameter is the name of config. This is the one. Okay, save it. Okay, so now what is the syntax of this line? So let's go here. Let's copy this line. Let's go to instance, text field, text file, and this will be my path. So project path. Okay, let's select this one and replace. This will be the name of the config, simulation config. Okay, so I have this one now, right? Let's see this one here. And this is where I will execute my config, right? So I can put them in the single line, but I will do them just separately. So I will start my command lines, cmd, and then here I will type cd. Now I'm here in the right location, as you can see, and I will run this config. It will run in headless mode, so Cameo will not be started. So I could actually close Cameo, close the project, close the Cameo. As you can see, I don't have any Cameo open. And as a result of that, I will get the file created into this package. It will, in any case, be created at the same level as a project. Okay, so now let's type it here, run it. Cameo is started here in the headless mode, right? So that takes time, and as a result, we'll get this file generated. The changes to project are not saved in this mode, so we just get the output data produced by the file, by the config to the file. Also, you can set up, for example, to read from file as a beginning. For example, from Excel, you can find this video on that, lookup table. It's called lookup table, which explains how to set up that and how to run this line, automatically. So you can put it as part of the scheduler, window scheduler, which would execute this line, right? Another way here you see this is Jenkins server, which can execute this, and then it runs and then gets results of the testing. So it takes some time to start Cameo, but once it is started, we see the execution happened, and that's it. It's done. We see the file is here. So everything passed and took a little bit longer, 1 second, 400 milliseconds. So this was the last part of this series of steps to perform to set up the model-based testing, complete sequence of steps with demonstration to set up model-based testing. There are more topics to cover with this sample. For example, MBSE method and framework for control logic modeling, covering analysis of stakeholder needs, then going to functional analysis and logical architecture, and system requirements and transition to solution architecture. So smooth path will be as a separate, maybe separate 3 topics. Then change impact analysis and system engineering collaboration when someone changes requirements and we get impact, and how to handle that, how to work in team. And the last topic is requirements information integration. So how to work with the independent requirement sources, changing again impact, but also storing requirements on database, synchronizing from the database. So thank you for watching this video. See you next time.